So with that, let's welcome Tom Campbell again, part 2.
Well, hello again. Okay, so I'm trying to remember where it is we left off, but I believe we had a larger consciousness system. We had a virtual reality that was created for we individuated units of consciousness to evolve the quality of our consciousness in. In other words, to reduce the entropy of our consciousness or to grow spiritually, if you want to put it that way. So you see this idea of love, spiritual growth, lowering entropy is fundamental too. It's a fundamental part of consciousness. It's what consciousness has to do to survive. So love isn't just a good idea, it's something that helps grease the skids. It's a fundamental part of what we are, what we're doing, and who we are. In a virtual reality, it's a little hard to get your mind around a virtual reality, because you've identified with your body for so long that seeing it any other way is really difficult. And sometimes people will say, well, does that mean that when I close my eyes, everything in front of me disappears? Well, only for you if you close your eyes. If there's anybody else, they're still getting data in their data stream defining what was, what's in front of you. If everybody leaves town and there's nobody there, does the city disappear? Well, there was no city in the first place, you see. There's nothing to disappear. All that city was data in data streams in a multiplayer game that was describing, that was interpreted, that data was interpreted as that city and the people in it and all the buildings. You go to bed in your bedroom at night and the system has and nobody else is in there with you. The system has no need to render your body, your avatar. It's just not rendered because there's no other player needing that data. It only renders data when there's a need for it, when somebody takes a measurement, wants to know, only when there's a request for the data. So while you're sleeping at night, your avatar is not being rendered. But when you wake up in the morning, you have that crink in your neck, that's being rendered. Okay. So somebody walks into the room and looks over at you, they see your sleeping body, and that's being rendered to them. You have to get this idea that reality is created in the mind of consciousness, in a data stream individual to each consciousness, and that data stream is interpreted as this reality. And once you get that idea, then it makes a lot of really strange things seem not all that strange. Okay, I just make a few up, like lights in the sky. If you go outside and there's this big light in the sky, and you look at it and it's nothing like you've ever seen before, and it doesn't seem to be a star because it's not nighttime yet, et cetera, et cetera. Well, what is that? In your data stream, there's a light in the sky. And you may say, well, somebody else come out and look at this with me. If they come out and they look up and they say, oh, I see it too, there's some data in their data stream that says there's a light in the sky, you see. Now, does that mean that everybody will believe you because you and your friend both saw the light in the sky? Well, of course not. Does that mean that it was real because both of you saw it? This brings up the definition of what is real. There's nothing more real than information. Information is as real as it gets. For you, it was real. It was real data. I've talked to people who've had experiences such that they heard a lot of commotion outside, sirens, flashing lights, helicopters flying over, and all the commotion seemed to be like 2 blocks away. And they were having a little dinner party, Everybody says, wow, what's going on? 4 or 5 people get up, go outside. Wow, look at all that stuff. I wonder what's going on. They see a lot of smoke. They see fire. Seems like a major building a few blocks down is burning. And there was something that the 2 of these people needed to do. There was an appointment they had that they had to go to in another part of town. So they get in their car and they drive off the appointment and they come back. And when they come back, they go to the neighbors and say, what was that? What was burning down there? Because they saw the neighbors out in the yard. Everybody was out in the yard looking. And the neighbor says, what? I didn't see any smoke. I didn't see any fire. What are you talking about? You see, there was data in their data stream. They saw it. So did everybody in their house. So were the neighbors out there watching it. But yet, later, neighbors, just about any of it, they didn't see anything like that. Now, the people in the house, they all agreed. They saw it. Now, why would something like that happen? I could say because the larger conscious system has a good sense of humor, and that's part of it, but it's more than that, because that was a lesson. That was a big learning point. That was an eye-opener for these particular people. They learned a lot from that experience, and it was important to their learning. Because the purpose that we have is to grow up, become love, lower our entropy. That's our purpose. We are the larger conscious system strategy to survive, to evolve. The larger conscious system is an aware, intelligent system. It's consciousness. It would like us to succeed because our success is its success because we're it. It's us. It will help us as we need help, as we can use the help. It will give us lessons. It will give us opportunities. It will try to wake us up if we're in a rut. It does all those sorts of things. Often that's what synchronicity is. The synchronicity, something just happens to land, right where you need it to be, right at the time you need it, and it's like 1 in a million, and that's synchronicity. You and the system can work together. And if you're open to it, then it'll happen more often. If you're not open to it, then the system's wasting its time, because if it happens, you'll just blow it off and say, or you'll deny it or something else, so there's no point. So again, that, it works that way. So this is a difficult thing to understand and to get your arms around. I know it's very hard to think in this terms of a virtual reality and data streams, because it's contrary to everything else you've thought about all the rest of your life and everything you believed, up until this time. So that's what we talked about last time. Just the idea that we're living in a virtual reality, and that our reality is created in the minds of the consciousness. Now we're going to, and I showed you an example, a quantum mechanics example of an apparent reverse causality. Really wasn't a reverse causality, but it looked like that because we did something, we created an image on a screen, then we did something later, and then the image turned out to be something other than what it was supposed to be. So it looks like what we did later changed what had happened in the past. But it wasn't like that because that image had never been looked at. That image wasn't in the reality yet because no consciousness had observed it. And it's not really the observation, that's the point, it's the information. The information wasn't available because nobody ever looked at it. So it really wasn't here yet. And then when we did make the measurement, things had changed. We'd erased some of that which-way data, as you remember. It's a different logical problem now, and it got a different answer when that measurement was made. So that's how that quantum mechanics works. I'm going to show you another false backward causality that, let's see, where's my pointer? It's hard to point to both of these, but I think most of you can see that one, can't you? No, it's not on yet. That'll work. Okay. I'll try not to get in your way. I'm imagine that we have 10,000 historical records. Well, let's not start. Let's make it easier than historical records. Let's start with just 10,000 random numbers. Okay, with 10,000 random numbers, we're going to break them up into 10 groups. There's the 10 groups, 5 here, 10 groups, 1,000 each. And then we're going to break each one of these 1,000 groups up into 500. Okay. Now, we're going to apply our intent to change the average value of these random numbers. These random numbers are picked between 0 and 1. Their average ought to be 5, 0.5, right? 0.5 between 0 and 1. But if you only had 10 random numbers, you wouldn't expect the average to come out to 0.5 because that's not a very big sample. If you only had 3 random numbers, it's even less likely that the average is going to be 0.5 because it's a small sample. But if you had, you know, 1,000,000 numbers, you'd expect that average to be very, very close to 0.5. Okay, that's what we call the natural uncertainty of the average. Okay, so we're going to use our intent to look at this group of 500, and we're going to want that to be an average that's just a little greater than 0.5. We're going to want to try to boost that average value up. These are kind of experiments we've done in Pear Labs, and a lot of other places have done these. We're going to take this and try to make it smaller. So what we'd like to do is to make it such that this is going to be bigger than that one. Okay, so you're going to make one side bigger, one side smaller. Now, our intent can only modify that probability within the margins of the natural uncertainty. Okay, so that natural uncertainty with the 1,000 random numbers is, let's say, 0.49, okay, 0.51, that's kind of the range, it should be in there someplace, then we're not going to make any of those averages end up to be 0.3 or 0.2 or 0.7. That's too much, okay? That is a phenomenon or a thing, a principle I call the Sigh uncertainty principle. It limits what you can do with your mind. You're limited to the uncertainty that's natural to that situation. I'm going to generalize the Sigh uncertainty principle a little later, but this is where it starts. All right, so if we do that here, and we have our people who sit and make this go lower and this go higher, there's a good probability, if these people are practiced and are good at this, that that'll work. Indeed, when they look at those two, this will be, you know, the 0.5, 01, and this will be the 0.49. It'll work that way, or 99. And there's nothing special about that because the scientists or mathematician look at that and say, yeah, well, that happens all the time anyway. That's what we expected. But if we also do it with this one, and this one, and this one, and all 10 of them, and if in all 10 of them, every one of them has the one on your right is higher and the one on your left is lower, that's equivalent to flipping a coin 10 times and getting heads every time. Now, that is not likely. And, that's way out of chance. But these experiments have been done, and indeed that's what the results are, because it's not too hard to make this thing change. So as long as you are working with your intent on a single unit like this, you're limited to what you can do within the natural uncertainty. But that can very soon turn into something that is hugely improbable, that you're able to demonstrate the ability to do this in a small way. All right, so that's Sigh uncertainty. But now we have to look at this and look at the constraints. There's other constraints. What if I ahead of time take this 1,000 and I look what the average is? I take those 1,000 points and I find out what the average is. So I know that. And then I start to work on this one to make it go higher and this one to make it go lower. Can I change them? Yes, I can change them, but as much as I change one to go higher, the other one will change exactly that much to go lower so that I get the value that I measured. That's already known. You see, this is a known fact now. I've already looked at that. Once that fact is in this reality, the other facts are limited by that. So if I look at the whole 10,000 of them and got the average for that, I could change all these things up and down, but when I was done, all of them added together would have to be exactly what they were when I measured the whole 10,000. Okay. Now, I also told you in the quantum mechanics that there was a delayed erasure experiment. What happens if I look at each one of these 1,000s, and I know what they are, and that will offer constraints on all of those, but I don't actually look at that data. I have it, I record it, the computer computes it, stores it in a place, and that storage gets destroyed in a lightning storm and it melts it, blows it up. No data in there anymore. Do I still have constraints? No, constraints are gone. Now I can do it just like I did before that was done. So the thing that's key here is information, because this is an information-based reality. So if you have information that limits what can happen, now you have to work within that limitation. You remove these limitations. If you don't have that information, there's more things that you can do. You see, you have more flexibility in what you can do. Now, this was first done with old data of length of stay in a hospital. So they went back a decade, old data of how long people stayed in hospitals. So they got 10,000 pieces of data that said, you know, Joe Schmo and Mary Smith stayed this long in the hospital, and so on. And they broke it up into groups. And one group, they used their intent to make that hospital stay less, to make these people healthier, to make them less ill so they didn't need to stay there any longer. And they found that to within a very strong statistical significance, the people that they used their intent indeed had shorter hospital stays. See? Than the group that they didn't use their intent. And they could do this consistently. And they said, oh, retrocausality. We're changing the health of people who got out of the hospital, 10 years ago. We're changing their health while they were in the hospital to get them out early. But as you see, there's no real retrocausality. It just appears that way. It appears that way. It doesn't actually exist. What they were doing was modifying the average value of data that had never been looked at. This hospital data was just hospital data sitting on a database. It was a decade old, after all. Nobody had any idea what the average hospital stay was. It was virgin data. So it could be manipulated with intent. Works the same way with the double slit experiment I showed you. That which way data is information. It's not so important that somebody sees it. It's not really the act of observation that's important. It's that somebody can see it. You see? It's that the information is there and it's seeable. That's enough. That puts it in this reality. The information is available for somebody to look at. Now, once you know that information about what slit it goes through, all you get is all the particles fall in those two lines. And without that information, you get diffraction patterns. You see, the information's key, not really the act of observation, but it has to be available to be observed. So that's the nature of the way this reality works. Okay, so yes, information can come and go. And yes, we can make things so that we can change them, manipulate them within limitations. And yes, we have more flexibility to do that if there's more uncertainty. This is tied very closely with uncertainty. If you have more uncertainty, you have more possibilities. See? Now, that's a major one. Let's do the next one. Okay. Now we're going to talk about the future here. Okay, I showed you a slide last time that had a bunch of letters in the slide, right? Some had 26 Ks in it or something, and different number of A's and B's and C's, and those were 26 different possible outcomes and the probability of that outcome happening, right? That's what we had. Okay, when that's the way the reality works, then the system has to know what all these probable futures are. Because every measurement you make, again, every time you open a refrigerator door after you've been away for a month and don't really remember what's in there, right? Data was erased, now you don't know. Well, what's in there is going to be a random draw from the probability distribution of the possibilities. That's what's going to be in that refrigerator, right? But it's constrained by the probability, so you're not going to open it and find, you know, a live chicken. You know, that's not very possible. You know, that probably is a zero possibility. So that's not in that group. But you know, whether there's, you know, 5 cans of beer in there or only 4 cans of beer in there, either one of those about the same, perhaps, if you just don't remember, then you'll get a random draw, and it'll be one or the other. Or maybe there'll be 3, or maybe there'll be 6, but it'll be something that's totally believable, and that's what will be there. That's the way the reality works. In order to do this, the system needs to have at its hand everything that could possibly happen and the probability that it might happen. Now, you might think that's a lot of things. It is. But there's some constraints on things that aren't significant, like whether I scratch my head with this hand or this hand doesn't really affect, doesn't have any causal chain attached to it. So those kinds of things drop off very quickly. So we have this database, probable future database. And here's a cartoon of it. I've got here, I have it in just 2 dimensions, and I have time being on the radius. So you can see time is greater as you go away from the center. And these little peaks, these green peaks, are probabilities. That's a probability distribution. As time gets greater, this pie pan just gets longer. And there's some things, you notice as you get close to the center here, well, what's the hole? The pinhole at the center is the present. That's it now. Okay, because the T's are times into the future. So that's now at the center. So this whole pie, if you will, this whole plate is like a cloth that's being drug toward the center and disappears in a hole in the middle as those peaks come in. There are some things like, you know, like maybe these peaks out here that are really pretty tall and pretty far out. Most of the stuff that's up really close is a lot higher because, you know, things that are only going to happen an hour from now are, you know, the probability, the constraints start to get put in around them, and they have less and less uncertainty as to how they could be. Well, that less uncertainty means fewer possibilities, which means the probability is going to go up among a fewer number of possibilities. So sometimes there's things way out here, though, which would be if you were a prognosticator betting on something happening in the future, that would be a good one to bet on. Some things like this one could be here. There's some kind of a range of things that they're not too probable over. And most of the stuff out here is just pretty low. So this is just a cartoon to give you a sense of what I'm calling the future probability. It's the probability of all the things that could happen. Now you think, well, how do they know all the things that could happen? Well, this is a computed reality of all us avatars. We are in a specific position of things that we're having or doing, and it's the next delta T. There's a finite set of what can happen next. And the system has all of the information of what happened before and before and before that, you see. So it knows you very well. it's got a dossier on you of all the choices that you've ever made up into this time and all those circumstances, all your intents, all of your, your feelings about it, your thoughts about it, and so on. So with that historical dossier, here you're faced with a choice, it's got a pretty good idea what you're likely to do. And it's only making that guess one delta t at a time. It only has to guess out a delta t. How big is a delta t in this virtual reality system? About 10 to the minus 44 seconds. How hard is it to guess what you're going to be doing 10 to the minus 44 seconds from now, right? Just about the same thing you're doing now, because you're not going to change much in that amount of time. So then it gets progressed on out with an assumption. The assumption is if, what our guess is. We're going to guess at what we think everybody will do. It's just a guess based on history, what you've done before. We're going to guess what it's going to be. All right, that'll be the next delta t out. Then if that's right, an assumption, we'll guess what the next one would be. And if that's right, we'll guess what the next one's going to be. And so we can run that out, these lines of t like this, we'll run that time out as far as we want. But notice, the further out it goes, I'm stacking assumptions up, one on top of the other on the other, the rattier the prognostication is. You can only take it so far before it doesn't mean anything anymore. So you can only make a probability distribution go out so far in time before things don't really make sense because you have too many assumptions. Okay, let's say we finally we're right here at the center, and this delta t comes up, and the system is ready to see what happens. What happens is we all make choices based on our free will. So some of the predictions it made of what we were going to do next were wrong, because we've got this free will, and we can do anything we like. We can be kind of odd and unusual sometimes, even if it's out of character. We can do that. Well, what does the system do then? The system has to take that point and from there on recalculate that probability distribution out to all the things that change interacts with. It's not everything, just all the things that change interacts with. And it may be that it only interacts with a couple of things before it really doesn't matter anymore. So it's not that big a job. So you've got this database has to be there to support this idea that what happens here when we make a measurement is that we get a random draw from a probability distribution of the possibilities. Okay? So what happens now as this time goes on? Well, all of this probability distribution slides through the pinhole at the center, comes out the other side as everything that could have happened in the past and the probability that it would have happened. Okay, that's the database. That's the past database. There's a thread through that past database, which is what did happen, what we did choose with our free wills. So we have this big past database that is in two parts. The unactualized past, which is all the things that could have happened that didn't, and the actualized history, which is all the things that did happen. One's just a thread, a trace through the other. So these are the databases. Now, these databases are available to be queried by intent. The database is necessary because of the way the virtual reality is implemented. And we know it's implemented that way with the random draw because lots of things, particularly in quantum mechanics, work out that you can describe them perfectly based on that assumption. So that's one way. And from our experience, it works that way. This is a probabilistic-based reality. It's not all deterministic, probabilistic-based. I'll give you a good reason why it's a probabilistic-based and why the system would have chosen this kind of a process, or I put it stronger, that the system would have to choose this kind of a process. This isn't just a random choice. This is a choice it has to take logically. Okay? This is a big computation. And a statistical simulation is so much easier with so little processing and so much simpler than a deterministic processing. Let me give you an example. Let's say we take a simple machine like an old Civil War cannon, right? It's very simple. Hollow tube, throw in some powder that has a wick to it. You throw in an iron ball on top of it. You light the wick. It burns. It lights the powder. Creates a lot of pressure. Pressure pushes the ball out the other end. Simple machine. Okay. But remember, that's a virtual cannon with a virtual wick, virtual powder. And if you were to calculate deterministically where that cannonball is going to land, it would probably take the superest of all the supercomputers we have, all week to do it. If you did it down at the atomic and molecular level, if you actually looked at all the molecules in that burning process and in the power, because it isn't going to burn evenly. This part will burn before that part, and the pressure will move it around more. And the barrel isn't exactly cylindrical, and the ball isn't exactly round. And you get down and the way the thermal energy gets dispersed through it, every time is different. It's different. One reason, just because once the ball goes out of that cannon isn't the same anymore. That barrel actually flexes. A little bit of material is worn away. It's a different problem now. And does that make a difference? Well, it does at the atomic and molecular level. It makes a big difference in what pressure is where. You see? So a calculation from the ground up is horrendous just to do that simple thing. Billions and billions of things to compute at the atomic and molecular level. You probably wouldn't have to go, in this case, to the atomic. You just probably go to the molecular level. But that's an enormous problem. And every time any cannon is fired, you have to do the whole problem again because there's different things there. You see, the barrel's a little worn. Now the temperature's different. The barrel's a little warmer than it was. It flexes a little different. It expands. It contracts. Everything changes. So every single shot that's fired, start over from the ground up with a billion calculations, weeks worth of calculations on a supercomputer. That is the grounds up deterministic. That's the way a simulation is done with determinism. Here's the way you do it with statistics and probability. It's a virtual cannon. So if the cannon exists, avatars build it, the larger conscious system has modeled it because that's how they get the data from it. So it has a model of that cannon. So the larger conscious system fires that cannon a million times, sees where all the shells go. It does this deterministically, okay, where all the shells go, and then it does a probability description of that. Oh, well, most of them fell this far from the parabola trajectory. Some of them fell this far and that. And here's the pattern that they have. If you look at that, and if you do that for even 1,000 shells, you get a real good idea that the next one is going to land in there someplace. And they can even say, as a function of number of shells fired from that cannon, how does that pattern change? So that can just be done experimentally, calculated. Consciousness is fast. Its computer is really good. So it does that, but it only has to do it once. Now, all of the cannons like that one in the whole war, all it has to do, you fire a cannon, go into probability distribution, take out a number, there's where the ball went. See, simple. It doesn't have billions and billions and billions of calculations to do. It simply looks at what's probable, takes a random draw from that probability distribution and say that ball landed here. Next time it's fired, takes a random draw from the probability distribution, that ball lands there. See? So in order to be parsimonious in the simulation, it's a computer term that means being efficient and being effective, you have to move to a probabilistic simulation. A deterministic simulation is just silly. It's way too hard, and it's not necessary because the only reason that anybody uses a deterministic simulation is because they don't have enough data to make a good probabilistic one. Otherwise, they do a probabilistic one if they had the data to precisely define the probability distributions. Anybody would do that because you get the same answer. It's just a whole lot easier. And the larger conscious system can always have very precise probability distributions because it has everything. Everything here, it's modeled in this big computer. And its time step has billions and billions of cycles between every one of our time steps. Our delta t at 10 to the minus 44 seconds is big, fat, compared to what consciousness system runs. So it's got lots of time between our delta t's to do any kind of analysis that it needs. So anyway, that's why it needs to be a probabilistic system. And this random draw fits all the data, scientific data, that's the way it's done. Given that, you're going to have this probability distribution because the system doesn't want to have to create these on the fly. It would like to do as much as it can ahead of time. So what do we traditionally call these databases? They're called in Hindu theology Akashic records. Those are the Akashic records. That's where all the data is. Okay? Now, how do you get data out of that database? With intent. You simply have an intent because you are consciousness. That database is a part of consciousness, and your intent works like a query in a database. You intend for a very specific piece of data, you'll get that data back. Okay, now notice we have a probable future, we have a unactualized past, and we have an actual past, an actualized past. All of that data is there. And what do we know about database querying and retrieval? It's essential that your query is exactly right. It's just what you want. You know, if you have a general query, you'll get a general result back. You need a specific query, as detailed as you can. And often you'll get a query and get data and say, well, that's not quite right. Let me adjust that query a little bit. And you'll get something back and you make adjustments till you get more of what you want. So it's really important that when you get data from a database, that you're clear on what you want. It's well defined. It has a unique address. You have to have focus. You can't have your mind jumping around on different things. It has to be focused on this query. It has to be clear. Okay? You have to be open to the information. You won't get the information back if you're not open to it. Okay? You won't get anything back. You won't even make the query if you're not open to it. Okay? An intentional query. So you need openness. As much as you have fear, which creates the ego and creates the belief, that will make it difficult for you to be clear and focused. Okay? That fear ruins clarity and focus. It jumps around. It's worried. It has performance anxiety. It has, am I going to get the right data? Is it what data I want? Oh no, I don't want it to be like that. You have all these issues surrounding it. You probably won't get much at all, if anything, or if you do, you won't even recognize it. And it takes time and patience to learn how to query the database. When you remote view, you're querying the database. You're asking for information out of the future probable database. Okay? And it's all there. The data's all there, but it's just probable. This is a probability-based simulation. It has to be. Anything else doesn't work. It's not logical. So that's what you're doing with your remote viewing. You're getting data out of a database. You can remote view into the future, and you'll get what's most probable at that time. If you're remote viewing something that isn't going to happen for 10 years, well, you know, the probability is going to be a little flaky out there. You may not get the right answer because a lot of free will choices are going to be made in the next 10 years that might change that. Okay? But if you're going to remote view something that's going to happen in an hour or a day or a week, well, the probability could be pretty stable for some things and still could be up in the air for other things. All right? So that gives you some sense of boundaries and limitations that you have based on time, how far out, and what the difference is in probabilities. Okay, now, you query this database not with your intellect. You query this database with your intent, but the intent has to come from the being level, roughly associated with your subconscious. Not exactly the same, but a similar kind of idea. It comes from the being level, not from the intellect. The intellect says, oh, I'd like to know about such. It's like making a wish. It doesn't carry any force. And maybe that would be, to give you a little example of that, the reason that we talked about before, the reason why you have to pick up all the trash in your office building rather than just ask the janitors to do it or snap your fingers and have it go away is because our purpose here is to grow up, lower our entropy. When we do that, we change. We're a different person when we grow up. We actually change ourselves into be somebody different, more grown up. A lower entropy person is a different person, makes different choices than they were before. That's our goal. That's what we do. That counts. Making wishes doesn't count because it doesn't move you toward love. It doesn't help you grow up. It's this difference between acting and being. Acting nice, acting caring, gets you no points. It doesn't help you grow up. It's an act. Being kind, being, caring, that helps you grow up. That helps move you to becoming love, not acting like you're love. So if you go into your office building and you say, janitor, clean up this mess, you've got no involvement in it, really. You're just giving orders. That's like wishing at a wishing well. It's all from the intellect. It's not from the being. It isn't going to help you change yourself any. Therefore, it doesn't count. You see? That's why this thing about you got to do it. You got to do the work. If you don't do the work, it doesn't count because it's not changing you. You can wish all kinds of things and it doesn't make you grow up. That's the point here. The system only supports you growing up. The system doesn't support you making wishes. That's irrelevant. See, or getting other people to do your work for you. So it's all about you growing up. Well, that's the same way here, getting this database, getting this information. So that brings us to the last thing that I want to talk about on this one, which is another variable in how well this works and how successful you are, besides clarity, focus, and working out of the being level. Okay, which is working out of a level, and also, I guess I should add to that, it's not quite the same, but working out of a level that has no fear and has no ego and has no beliefs, because all those are limitations. All that's high entropy stuff. That messes it up. Wrong reason. So you do it for an ego reason. Oh, well, the reason I want this stuff cleaned up is so I can make more money, or I can, get a better girlfriend, or it'll make everybody like me better. Wrong reason. See, that's ego reasons. I want to clean this up because I want to grow up. I want to change. I don't want to be like this anymore. That then does something, you see. So this ego gets in the way, as does belief. I want this cleaned up because I believe it ought to be neat. Well, that's not important what you believe. It's important what you are. Okay, so the last thing that matters is the quality of the intent. If you have an intention that you need this data because, it would be fun, or because you could use that to make a better investment, or because whatever. Well, you want this data because you'd like to, remote view the ladies' locker room after the game, right? That's what you want this data for. You see, that is not very supportive of the purpose of the system. So the system's not very cooperative in working with you. See, so that's another constraint on your ability to query the database, is the quality of your intent. Is that a good quality intent? Now, just wanting to learn how it works and get connected with it and learn, you grow from, all of us know if you work down this path, even if it's just limited to remote viewing, it's a growing process. 10 years down this path, you're a different person. It changes you. You grow up. You start to see bigger pictures. That is, if you really are doing it, it's a growing process. Well, that's good. That's lowering your entropy. Will the system support that? Sure, it'll support that. Okay. If you, that's why Marty was saying when he, at the end of his first day's talk, he said, and you need to also be concerned about doing the greater good, right? And the greater good's important. Well, why is the greater good important? Why can't I just do this and, get rich or look at the girls in the locker room or whatever I want? It's just a system. It's a machine. Why does the greater good have anything to do with it? Well, the greater good has something very fundamental to do with it. That's the way the system's set up. It's about growing up and becoming love. And if you're working at counter purposes to the system does not go out of its way to help you. It may even go out of its way to block you, to get in your way, to give you some bad information or whatever else, because that's not the way it goes. Now, it will not do that by manipulating you. You still have free will, but it can certainly put blocks. It can certainly put things in your data stream that confuses the heck out of you and makes you maybe not do that anymore. Okay. We make up tools. Very few of us have so little fear and so little ego and so little beliefs that we can just say, database, I'd like to know about this. There it is. Most of us can't do that. Okay? We don't have that ability. If you did have that ability, you could do that. It's not that that can't be done. It can be done. It's just that most of us can't do it. So what do? We make up tools. The tools help us make the connection, help us get the answer. Okay? So now these tools, the tools can be all sorts of things. They can help us make the connection, and they can specify the output format. What kind of output format do you want? You get to tell the database. It's much better in Google. Google just tell you in a bunch of words in a list in order of how often they've come up before. You can actually tell the system, I'd like this data as a graph. I'd like to inquire about the health of Susie Q, and I'd like to see health on this axis, this y-axis, and I'd like to see time on this axis, and I want to see her health as a function of time. And if you're a statistician, you can say, I'd like to see the error bars on that out to a 3 sigma level, and you'll get that too. See? So you can get any format you want, or you can say, I want it in a picture. I want a picture of Susie Q, and I want everything that's healthy white and everything that isn't healthy black. Oh, and that black stuff's the stuff that's the problem, you see. Now that's a visual, that's a picture image you're getting the data. But you don't have to get it that way. You can get it in any format you want. That's part of what you can do. Well, there's lots of ways to create output formats that have meaning to certain people. And most of this is individual. You have your own ways of sensing, getting your format. How do I want it back? It's how do I want to see the data? Mostly remote viewers look for pictures, but they can work with clay. They can do other things. Doesn't matter. You can specify how the data comes. For instance, there's lots of prognosticators who come up with little tools they make up that do prognostication, and they work. Some of them are ancient, some of them are newer. The tools work, and the reason they work is the tool itself has a lot of uncertainty about it. Okay? It's an uncertain thing that the consciousness system can modify this way or that way, and if you look at it, nobody was ever noticed and modified. So it can do it stealthily, if you like, so that nobody really notices, because it's within the uncertainty of what that would be. So what am I talking about? Tea leaves? Well, if you look at tea leaves, it's pretty random what's in there. There's a whole lot of uncertainty about how those little chunks of dried tea are going to end up on the bottom of the cup, right? With all that uncertainty, the larger conscious system could make them fall in any sort of pattern, and you'd look at it and just look like tea leaves. Wouldn't mean anything. But if you develop a system that says, if the tea leaves come in 2 little bunches here and then a big bunch next to it, that's a family. And if the tea leaves do that, you know, that's a trip. Somebody's going to take a trip. And if the tea leaves do that, that means this. So if you come up with a code, if you will, a way of saying what it means, now you've created a format with which the larger conscious system can send you data. And nobody notices. So you learn how to read tea leaves. That's why you have to learn it. You have to learn the code. You have to learn what things mean. And as long as your intent is of good quality, you can go out to that database, get things, and your tea leaves will tell you what the answer is. That's just a different output format than a picture. Ancient people used to throw a handful of chicken bones. And the way those chicken bones fell, what was on top of what, and so on, and leg bones and other bones, and how it displayed, that would tell them something. Well, that's random. You heap a bunch of chicken bones in the air, it's very random how they're going to land. So you can make a system of which the system can tell you the future, give you information based on that system. I have to go questions at the end or I'll never make it through this. Okay, what about the tarot cards? You got to shuffle the deck first. That's the only way it works because that produces uncertainty. You see, once you do the really good shuffle, you got uncertainty. So then the system can work. What about the I Ching? Right, the I Ching, you drop a bunch of reeds or you can flip dimes or make pennies or something if you want. It's uncertainty. The system can then communicate to you through the I Ching because there's all these little hexagrams that mean something, and they can pick out a hexagram just what you need that helps you out because there's uncertainty. So this is how you can use uncertainty, you know, to produce a communication output format, and all these things work. People who read tea leaves really can tell you something about the future. We go to astrology, and it's got a component of that in it too. You got so many heavenly bodies out there and how they interact and which one influences which one at what time and so on, that you've got a lot of uncertainty how that can be interpreted. So you can get things that, you know, that work. You know, people who do horoscopes, they have to get in the same state that you get in when you do remote viewing. When they're going to do a horoscope, they get centered, they get quiet, they have intention, they get information. And their information is in terms of what they see. But there's a little more to astrology than that, but I don't really have time to go into it. But that's just one of the components of it. All right, now, when you do, I said a remote view, you're getting data out of that database. If you're doing the remote view in the future, it comes out of that database. Now, that database has in it everything that could possibly happen and the probability that it does. If you don't have a clear intent that you want to pick the thing that is most likely to happen, and you just say, database, tell me about such, you may very well get information back from some less probable thing. You could say, database, I want the third most probable thing in my data, not the first. But you have to specify. If you don't specify, then it's not a good query. If it's not a good query, you'll get noise in your result because sometimes your query won't be specific enough. Okay? If you're into the past, you've got a lot of unactualized past, just one thread through it, and if you don't specifically say, I want to look at the stuff on the history thread, you can sometimes get stuff that's elsewhere. Okay, now what happens when you don't make a good query? What happens is that you get a random draw from the possibilities because you haven't given it a good address. It's like sending a letter to Elm Street. Well, there's maybe 300 addresses on Elm Street. So the postman, if it's a conscious system, gets to Elm Street and says, that's all it says. It takes a random draw from all the homes that are on Elm Street, and that's where he delivers it. It's that sort of thing. You just get a random draw out of the possibilities if you don't narrow it and make it very precise. All right, let's see. So remote viewing is a direct query. You're doing a direct query to the database. Your output format is images, and all of your protocols, all of your processes, including the clay, including everything else you do, the cool down time, and everything, part of your processes, are tools that you create in order to help you focus that intent properly to get the information. And they're tools that you use to help you receive that information. You need the right mindset. So you practice making these tools. Just like people who read tea leaves, their tool is a way to decode the information. And it's tea leaves or chicken bones. That's their tool. So you have a database, and then you have tools that people make up to help them access the data more effectively. If you were fearless, no ego, a very loving being, you could just access the database directly. You wouldn't need any tools. You just send the query and get the information. And people do that. But most of us need tools. And the tools that we generate work good for some people and not so good for others. Tool sets aren't fundamental. Tool sets are non-fundamental. They're made up. They're human inventions. And typically, the tools that will work best for you are the tools that you create for yourself, because tools are metaphors. They're basically metaphors for the most part. Okay? And everybody doesn't speak or relate to the same metaphors. So if you work with something and it works for you, well, keep working and developing that. But don't be surprised if you try to teach it to somebody else that they have a hard time with it. They may have a tool that really works good for them because they relate to it more. It helps focus them more centered. It just feels better to them. Okay, so tools aren't universal. They're not fundamental. They're more individual. And any tool that you get, you go take a training course and somebody will train you in a tool and tool use, don't feel like you can't modify it. Modify it, experiment with it, try it this way, try it that way. If that doesn't quite feel right, do it a different way. Turn it into your own tool. Okay, so that's some things maybe you can use. Now there's another thing that's just as important as databases, and we'll get to that next. And that is that one of the aspects of this virtual reality is that your intent modifies this future probability. So we have this future probability that I showed you before. We'll just say that's a future probability. It's all the things that might happen, 26 things that might happen. With your intent, you can reduce the number of K's and increase the number of H's, reduce the number of S's, increase the number of A's. You can move those probabilities around. Okay? So when you do make that random draw, the probability of getting a K goes down and the probability of you getting an H goes up. You see? Intent. That was designed that way as feedback. What that ensures is that we have a hand in creating our reality. Our reality, we're co-creators in this reality, and it reflects us. So what we get is a reflection of what we are. Because what we are, our intents, our quality, those intents go into to create a reality that reflects that, what we are. You see? So reality reflects us. And if you look around at this world and you see that it's kind of ugly and it's got some awfully rough edges and you say, geez, things are really bad out there. It's a jungle. It's nasty. We're really a long way from love and peace. That's an accurate reflection of us. That's exactly who we are. It's not some accident or something that's imposed on us. It's us. The way we fix it is to fix ourselves, because you can't fix anybody else. That's the only way to fix it. All right, so let's go to the next one. Okay, these are the ones I'm going to skip. I was going to show you a whole bunch of things that in science and other places that this MBT solves, a whole bunch of things in science and so on, but that's kind of boring. We're not going to do that. We're going to go right through the remote viewing precognition part of the talk, because I don't want to cut my question time down. 25 minutes. All right. I need to hurry up then. Got to turn the page here, see where I am. All right. Okay, we said the first bullet there. It's a direct query. The remote viewing is data collection from a probable future or an actualized past or an unactualized past. That's why the clarity is important. You need to know what you're asking for, and you need to be clear that you give more precise things. Notice, you'll always have people, when you're remote viewing, that you say you have 6 targets. Somebody will show up that said, I got all 6, but I got them in the wrong order. I got the 3rd one first, the first one last, and they get all of them in the wrong order. Why is that? It's a fuzzy intent. If you intend to get the picture, but you're not real clear about which one, you'll get a random draw for the pictures. If you don't keep a real tight intent, you did ask very clearly that you wanted one of those pictures, but you didn't necessarily specify exactly which one. Or if you did, you couldn't hold that focus. It wasn't clear. You had that for intent for a few seconds, but then your mind wandered off and wasn't with that intent anymore. It was kind of doing other things. You see, you have to have the intent and hold it all the time that you're getting the information. Our intents wander around, so sometimes we'll get pieces of this and pieces of that because our intent isn't focused well. That's an unfocused intent that wanders around. Okay, now, you're not limited. Remote viewers a long time ago used to think that all they could do is remote view places on this planet. And then they realized, oh, we can go into the future and we can go into the past. When they were just doing them on this planet, they were doing the same thing. They were getting the same data out of the database, except they were getting it out of the current database, right? This database, this past database is only 10 to the minus 44 seconds old. That's the last entry. That's pretty close to now. So when you get data that's in the present, if you will, it's not exactly in the present, but it's so close to the present, it's just the near past. That's viewing things on this planet now. That's what remote viewers started out doing. Then they realized that they could go into the future, they could go in the past, they could occasionally get into the future that was improbable because they weren't clear in the query, or into the non-actualized past because they weren't clear with the query. And I don't know if they know it or not, but when you get into those databases, you can actually do what-if analysis. You can get into a past database and say, oh, here's the situation. I'm in the past now. I'm going to change something. I want to see the most probable result if such and such had happened. I want to see the probable result if Germany had won World War II. What would that have done? Show me how that would have fallen out. And I want to see the most probable things that would have happened, because see, the database has all the probabilities of everything that could happen. So it can follow down and says, well, if we make this change, then what would be probable after that, given that change? And it can display all that out. Or if you want, you could say, I want to see the 10th most probable thing, whatever. And if you don't specify, you have a fuzzy intent. May or may not work so well. You can do what-if analysis. You can do it in the future. You can do that as well. So there's lots of flexibility you got in getting around these databases. You just have to develop your own tools for doing it. Okay, you could go into the past and say, well, what state would I be in now if I hadn't forgotten my wife's birthday 3 years in a row? Well, and it'll tell you. It'll show you where you're likely to go. You see? So those kinds of things can be helpful. But you have to know kind of what you're doing. You have to be very, very precise with it is the key. If you're precise with it, you'll find that you will precisely get the same information every time. If you precisely go to that time in the past, you make the same precise change, you will precisely get the same thing. That's how I discovered it was a database and not something that was currently going on. I had to do the experiments over and over, changing variables to see what happened. And I eventually convinced myself that it was a database, because you do the same thing, you always get the same result. Anyhow, let's see other things. Limitations. Oh, before limitations, other reality frames. You're not relegated just to these databases. You can go any other place with your remote viewing. Your remote viewing isn't a whole lot different, actually, than lucid dreaming or even out of body. They're all related. They're all intent-based, but they have different objects. But fundamentally, they're not as different as people think. They have the same genetics, if you like, even though their applications are different. Okay? You can remote view some other reality frame that's not in this universe, anywhere in this universe. You can remote view other universes, other places, other virtual realities. They're there. But the problem you have is how to specify your target. If you've never been there, you can't specify your target very well. So you have to do some exploring. Often you do your exploring with very sloppy intents because you can't make it narrow, and you just eventually learn the map by going out and coming back and going out and coming back, and when your 100th time you have a little better idea what's out there, and now you can go precisely back to that thing or that person while you were out there. Your intent can connect you to other entities, whether they're here in a body or whether they're not. Deceased or not, doesn't matter. Your intent can make that connection. It's all part of the database. Okay. So when you make a connection, for the most part, when a medium makes a connection with a dead person, let's say they've been dead for a decade or so, they're just getting into the past database. Now, most mediums would go, it's not just a database, they're real. Information is as real as it gets. And what's in that database is exactly what that person was. Every thought, every idea, every attitude, every feeling, everything is there. Every memory. The only thing that's not there is free will because it's a database. You see. It looks like free will because you can say, well, what would happen if I change this? But you're just processing through probabilities. So you're getting data out of the database because that person has gone on to do other things in other places with other people. You see, people don't die and then sit around waiting for somebody to ask them a question. They've moved on, but you can get all the information. There is no difference between that person and the one that lived. You see, it's everything there. You can ask them where they hid the gold, and they can tell you, and they're the only one that knows, and they can give you that information because that database has all the information. They can even give you comments on current events. Hey, Grandpappy, what did you think of the election? And you will get a probable, what Grandpappy probably would have said based on Grandpappy's file about the election. So you can talk to them, you have current events. It's very difficult to tell that it's a database unless you really do some research there to see how that works. All right, see if I've missed anything. Sigh uncertainty I talked about. Sigh uncertainty is limited to the natural uncertainty, right? Well, you have technical sigh uncertainty and you have social sigh uncertainty. It's a different thing. Social sigh uncertainty is limited to something a little different. It's related to the uncertainty in the whole system, in the whole virtual reality, and how that relates to entropy. Okay, what I mean by this, that is, let's say, for instance, you've got a lump on your arm here, and you're not sure what it is. That's the time to heal it, because there's a lot of uncertainty there, right? A lot of uncertainty there, so you can heal it pretty easily. Go to a doctor, he does a biopsy, he says, you've got a malignant cancer and it's the kind that'll kill you in a month. You say, well, let's get another opinion. The fourth doctor says the same thing as the first doctor. They all say the same things. Now, there's not much uncertainty there. it's really hard to heal. Earlier, it was easy to heal. Later, it's hard to heal. See, uncertainty makes a difference because now healing is just modifying that probability distribution. That's what healing is. You're modifying the probability distribution to, in the future, be healthier with your intent. Intent modifies future probability. Placebo effect. Intent modifies future probability. Positive thinking. Intent modifies future probability. Getting that empty car slot to park in when you get to work because you've had your mind working on it the whole time you've been driving in, and just as you get there, somebody backs out and you pull right in. Yeah, okay, I do. Let's see, I want to jump to questions here. That is just modifying future probability. And, what am I running out? I only got 10 minutes left? Okay. All right, we'll go to questions. I wanted to tie it into the ectoplasm, to why it is back in the 1800s, all this stuff could be done and it's not being done anymore. There's all good reasons for all of that that are easily explainable. So if you want to ask the question, you can ask those questions. So. Yeah, Sunday. Sunday I will be here after.
We were staying in this room Sunday. So when it was supposed to end, Tom Campbell is on after the normal end.
All right, so let's do questions now.
I just wanted to
No, you.
Can you guys go up to the podium? You guys have questions?
Yeah, come up and talk.
I wanted to say something about the part of when you were talking about querying the database and getting information. And there was one part where you talked about some people, when they're querying a database, the intent, sometimes only one person knows the intent of something. And I want to just give you an example of what I found out to validate that. I did a study about climate change and global warming and all that. This is not a political discussion, but I wanted to say I found out later that the original climate, condition that people said, this is what it is, this is the facts, was all done through a computer simulation. And nobody on the outside got to know the questions that were being queried into the computer at NASA to know how they came with that output. So the intent does drive the findings, and that was, so I just wanted to tell you that that's an example where the intent of the researcher or whoever's doing it makes a huge difference on how the experiment comes out.
Absolutely.
Yeah.
Absolutely. It's very difficult to remove the experimenter from the experiment. Your elementary school teacher who thinks that she's got the dumb kids, those kids will do worse. The teacher that thinks she's got the bright kids, so she treats them like bright kids because she has this intention. And she gives the kids that intention. Oh, you're all bright, so they all feel bright. The other kids all feel dumb because, well, you're the dumb class. Don't worry about it. You're the dumb class, They all do poorly. That's intent. Modifies future probability. It turns out that way.
Japanese history. My teacher didn't like me.
Yeah. If you think about it, that will solve an awful lot of the problems of why things are the way they are. Another question.
Okay, so say I'm managing a group, a prediction group, an app.
So say that every Wednesday I task a bunch of remote viewers to predict a baseball game on Sunday. So the question is, will a viewer that sends me a transcript on Friday be less accurate than a viewer who sends me a transcript 5 minutes before the game?
Not necessarily.
And can you bring up that probability, the table again? The future probability reality surface slide?
Yeah.
Because it relates to that. So prediction is closer to the center.
Exactly. Not necessarily, though. See, in general, that's probably true that the probability is more settled. Now let's think of very close games where the teams are evenly rated. That probability is changeable or, very easily changeable. But if we're talking about a game that's got a 50-point spread or something between the teams, that probability is much more fixed, doesn't change much. But sometimes things happen. Things happen because the star quarterback comes down with the flu while he's in the locker room just before the game starts.
That's what I wanted to know.
Yeah, you see, those things happen. So your best bet, I would think, in doing what you're doing here with chance and gambling, is that you would want to look at teams that have wide spreads. Now, the problem there is that everybody else kind of picks the winner too, because the winner is so much more highly, thought of than the other guy. But in those events where something unusual happens, like the quarterback with the flu, the system knows that, but nobody else does, because nobody's going to give that information out. So that's a piece of information that only the system has, and maybe one or two other people. Or let's say the quarterback is going to be having the flu then. He doesn't have any symptoms yet, but the flu's on its way. The larger system knows that too, and nobody else does here, because he hasn't shown any symptoms yet. You see, now your remote viewer gets that data. Well, now if you get that and it's strong, that's the time that I'd put some resources on that, because now you've got a lot of leverage, which, with a 10 or 20 to 1 chance. And you're actually getting information that is only privy to consciousness, and other people don't know. If they knew it, the odds would change. If they knew that star quarterback was going to have the flu, boy, those odds wouldn't be spread that much, because he's the one that carries the team. You see, so that would be a place where you wouldn't necessarily play a lot, but when you did play, you'd have a lot of possibility.
So will it be a very small difference if someone makes their predictions on Friday instead of Sunday right before the game?
It'd probably be a very small difference. And the closer those teams are together, probably the more difference it would make, because there may be just little things. It's going to turn on small things.
So as a group manager, I should pick games where where the teams are very close or the teams are very far away?
I would say it depends on what your goal is. If your goal is to make money and put the least effort in, I'd say pick them where the teams are far away. But where your remote viewing says, yeah, it's the one that's everybody thinks is going to win, I'd kind of let those go. But if the one that says the one that everybody thinks is going to lose is going to win, I'd go put some resources on that one, because there's a chance that that's based on knowledge that nobody else knows.
Okay.
A chance that if you get a strong indicator there, not a weak, but if you get a really strong indicator on a long shot, I'd bet on the long shot.
Okay.
Yeah. Another question?
Can you please go up if you have a question?
Oh, I see we have one coming up. Come on up. Come on down. Yeah.
The object of this is to get the end result. We don't necessarily care. When we're doing remote viewing for ARV, we don't care what precedes the event. We don't care about the quarterback. We don't care about the team. We care about the end result, the score.
Right. That's a tool.
And that's the only tool we pay attention to.
Right. You look at that tool, and what you're seeing is the winner. You're asking, show me I want to know who the winner is. It's basically what you're asking the system. And the system at that time tells you who it looks like the winner will be. And that works.
No, it doesn't tell you who it is. It tells you who the winner is.
Yes.
It's not a possibility. It's a fact. If you've read the information correctly.
It's not necessarily a fact. It isn't a fact until the game's over, because things can change. See, when you get that probability, the system may not know. See, random stuff happens too. This is free will. Randomness plays. So let's say you did it an hour before the game, and it says, it thinks Team A is going to win. Well, in the middle of the game someplace, some key player might have their leg broken. Big difference. Probabilities all change now. So it's not a given that what you get, even if it's right at the time, will still be right at the end.
But the way I understand ARV, with the target being after the game, all the stuff that precedes that is academic. It doesn't mean a thing. It's the end result that you're looking at.
That's true, but you're asking the question before the end of the game, and the data that you're getting back about the end of the game is based on information before the end of the game. It's not, otherwise, what you have is determinism. You see, if it's not that way, then it's deterministic and it can't change. When your tool says, look at when the game's over, what the feedback's going to be. That's your tool. But that tool is all it's doing is doing a query of who, the information of who's going to win the game at that time with what the information they have at that time. That information can change. So even though your tool is doing that, it's just a tool. It's the way you focus to get information. But the information is based on what's known now. So you can still, that player can break his leg, the whole thing changes. You see, if that's not the case, you have determinism, that it can't change because you saw the future. You're not really seeing the future. You're seeing a projection of the future that's probabilistic at the time that you ask for it.
I agree with you. Yeah, go ahead.
No, I was just going to say, that's an important point of view. And there are other points of view. And we'll talk about that actually tomorrow, and he'll be able to answer more questions.
I agree with what you're saying, but I think the thing is, you see the future. If you see the future, the question becomes, is it real? Is it going to happen?
You only think you're seeing the future. It appears that you're seeing the future because your tool is to get the information out of the future. But the information you get is not only the information that's there at the time you ask.
Based on probabilities.
Based on probabilities.
Okay. Still a question, but I can't answer it.
So it's the appearance of getting future information.
Yeah.
And in general, it's pretty good because in general, the system is pretty good at its guesses. It's very seldom that it makes a mistake. So it's a good tool.
But I see the difference between determination and...
Yeah, determinism and free will.
So let me make a comment, if I could, because there seems to be a terminology thing. What we're doing here is precognitive remote viewing.
Right.
Because when you're talking about associative remote viewing, that's not necessarily precognitive, because you can remote view something that is somewhere, and that's remote viewing. What we're doing in this room is we're also looking at the future. Yes. Yes.
That future comes out of the probable
And
database.
that's all the issue of probable future, whether it's not. Well, I'm really going to talk about that tomorrow. But it's an issue. I mean,
Yeah.
the data, we never are 100%. So it's a little bit hard to prove.
Step right up and talk.
Okay. We will talk more about that. It's a key question.
Okay, so this is a bit open-ended, but what if something is, how can we put it, a construct that, let's say, half the Earth believes, half the Earth has a different view of, and might violate some rule set that we don't know. So as an example, I want to remote view your last past life, the happiest time in your last past life. Obviously, that's assuming that we had them, or that you had them, right?
That I had a happy past.
Well, no, that you had a past life, not this life,
Yeah, but I had
a
a past
body
life.
before on this
Yeah,
plane of
right,
existence and
right.
so on. Okay, well, maybe half of the Earth believes in past lives and maybe half doesn't, for example. How do you see the conscious creation matrix working in that case?
Well, you ask the question. If it has the answer, it'll tell you. Okay. Now, reincarnation comes out of this as logically necessary for the process to work. So in this case, I'd say that if you ask about past life or what's in it, then it will be able to get that information. Now, there are, again, constraints. If the reason you want to know that is so you can blackmail somebody or do something else, then you probably won't get the information, or you'll get wrong information. If it's not, if it's something that is a good, up and up thing to do, then you'll probably get the right information. Another thing I should mention is you get information, and the information comes from the system, but you have to interpret that information. And there's a lot of noise in the interpretation. That's another limitation. When you interpret that information, it's very noisy. because you have to interpret it in terms of your own understanding, your own metaphors and things that you get. And that's often not a precise process. So you would get the information. And if somebody who had no belief whatsoever thought it was perfectly ridiculous about past lives, said, all right, system, tell me about my past life, they'd get information. Doesn't matter what they believe. That would be irrelevant. You ask for information, you'll get information.
Okay, thank you. So you don't really see any constraint on our abilities. For example, we can't, for whatever reason, not see our past lives, as an example.
Well,
the rule sets.
Yeah, if you have a fear, if you have beliefs, if you have things, then you won't process the information. Right. The system may send it to you, but you'll say, well, that's nonsense. I just made that up.
Okay, thanks.
You won't process it. Yeah.
Okay.
So yeah, beliefs and fear and all that stuff has a lot to do with what you get and what you don't get. But it's not that it makes the system either work or not work. It means you toss the data out, you refuse to see it, or you refuse to ask the question in the first place.
Okay, thank you.
Yeah.
So we're consciousness. We create a virtual reality to come in. And then while we're in here, we ironically, because our nature, create computers which are now progressed to virtual realities. Is it possible that somebody can make one so productive that a consciousness may want to go into that one?
Yes, absolutely. But notice that the consciousness is still coming from the same place. It's still the larger consciousness system. So here we are, and we're this virtual reality. Inside this virtual reality, we create another virtual reality on some very fast computer that we have here. Some fast virtual computer is making another virtual reality. And if that virtual reality has players who can make non-algorithmic decisions, they can make free will decisions. In other words, you've given them enough uncertainty in their process of learning, what their experience is and how they make those decisions, then that player becomes that character in that virtual reality within the virtual reality becomes an avatar of interest to some individual unit of consciousness that would like to make those choices. So they can log on to that. See, it's all the same system. It's all part of the larger conscious system. This virtual reality, the virtual reality within this virtual reality, all belongs to the larger conscious system, and all the consciousness really belongs there. So it's not that the character in the simulation becomes conscious. It's not that the elf is conscious that you make in your game. It's that the elf plays an avatar within a rule set that is attractive for some other IUOC to log in and make those choices, because those are choices at which you can help it grow, you see. And there's IUOCs at all levels. Bumblebees are conscious. Is there somebody playing bumblebees, or are they all played by the computer? Well, hard to say. There's NPCs here too, non-player characters, who come and go sometimes. So that's, yeah, so we can do that.
Thanks,
yes, the
Tom.
answer is yes, that works.
Thank you for sharing so much with us.